Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, welcome to Wednesday Night Math Night. I am so excited to be back with you. Priya did an excellent job last night. I always love letting her come on and do math night with you guys, but I am back. So welcome. I always like to start with a little question and answer in the beginning because it really helps me get to know you guys. So my first question is, where are you from? What test are you prepping for? And what is going to be my question this week? I always like to do a get to know you question. So the last time my question is are your Christmas decorations up yet? Even though it was only like November 2nd. My Christmas decorations are already up. I already have my garland sitting on my table. The only thing we don't have up is our live Christmas tree because you can't buy live Christmas trees November 1st. But if you had to choose a collection of nutcrackers, a collection of snowmen, or a collection of gnomes during the holiday season, which one would you pick? I would pick holiday gnomes. I have a collection of nutcrackers, but I think I would switch it to holiday gnomes. I don't know why. I just like the way I think they're adorable. So where are you from? What test are you prepping for? And would you have a collection of snowmen, nutcrackers, or gnomes in your house for holidays? Hi, Milagros. It's good to see you. I love seeing you every week. And all right, let's go ahead and get started with the first question. I guess it would help if you could see my screen. So let's get going. There's the screen. Technical difficulties tonight. All right, where are you from? What test are you prepping for? And would you have snowmen, nutcrackers, or gnomes? Hey, Winona, you're all the way from Michigan. I have a good friend that lives in Michigan studying for elementary education, and you would have snowmen. Gosh, snowmen are so cute. All righty. Hey, Joseph, good to see you. Collection of nutcrackers. I do love my nutcrackers. All right, I just can't make a decision. I just love all holiday decorations, let's be honest. All right, look at the following equation. What is the value of x? Gotta love it when my pen goes flying. I'm all over the place tonight. What is the value of x? So we see that this says 3 to the 2x power minus 6 equals 81 to the 4th power. So how do we solve an exponential problem when the variable is in the exponent? Well, this can be a little tricky. This is definitely for my middle school and high school people. So in this situation, we need to figure out how to find x. And the way we're going to do that is by getting the bases the same. So I need to get my bases to be the same, because if I can get my bases to be the same, then my exponents automatically have to equal each other. For instance, if I had 2 to the 5th power equals 2 to the x power, x would equal 5. Because if 2 to the 5th power is over here, then 2 to the 5th power would have to be over here. So x would equal 5. So if my bases are the same, I can set those exponents equal to each other. Well, how in the world am I going to get a 3 to equal an 81 or an 81 to equal 3? I'm going to turn one of those bases into an exponential expression. So 3 is already at the smallest it can go. So I'm going to take the 81 and figure out, can I turn the 81 into a 3 to the question mark power? Are you following? So let's think about this. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So 81 can be substituted out for 3 to the 4th power, because 3 to the 4th power equals 81. So I can literally substitute out the 81 for the 3 to the 4th power. It's like if you have a football game, I can take the quarterback out and put a substitute quarterback in. But I'm not going to take the quarterback out and put a running back in for the quarterback. In this situation, these are the same. So I'm going to keep the rest of my equation the same. And I'm going to replace the 81 with a 3 to the 4th power. That does not mean this exponent disappears. That's the number one mistake people are going to make on this exact problem, is they're going to call it here. They're going to stop here and then set 2x minus 6 equals 4. However, this only replaced the 81. But then I have to put that to the 4th power, because this 4 is still in play. You following? Now I'm going to simplify that. 3 to the 2x minus 6 equals 3 to the 16th power. Why is it the 16th power? This is for everybody, K through 8. Everybody needs to or K through 12. Everybody needs to understand exponents. So exponential rules, we're going to go on a total side tangent over here. That's a really thick marker. Exponent rules say that if I have x to the a times x to the b, that equals x to the a plus b. If I have x to the a divided by x to the b, that equals x to the a minus b. I might be speaking gibberish for some of you. I will explain it in a minute. I'm just flying through this. If I have x to the a to the b power, that equals x to the a times b. Why? Because if I have x to the 4th power times x to the 3rd power, what does that mean? That means I'm doing x times x times x times x times x times x times x. Well, how many times am I doing x? 7. So this equals x to the 7th power. X to the a minus b is the same concept. If I have x to the 4th divided by x to the 3rd, that is x times x times x times x divided by x times x times x. Well, when I divide something by itself, it equals 1. So this ends up just equaling x. 4 minus 3 is 1. Here's the one that we need to know. X to the 4th to the 3rd. Think about what an exponent means. An exponent means that I am doing that many times. So this 3 means I'm doing x to the 4th 3 times. So I'm doing x to the 4th times x to the 4th times x to the 4th, which if we use our understanding from this rule would be x to the 12th, which is why we multiply them. Let's go back to our problem. So now that I have my bases the same, I can literally just set the exponents equal to each other. 2x minus 6 equals 16. Now, I've gotten to this point in the problem. Everybody K through 6 needs to understand this next process, how to solve for a variable. I'm going to undo what's being done to the x because I want to get x by itself because we're trying to solve for x. So I'm going to kind of do the reverse of the order of operations. I'm going to add 6. Well, I'm certainly not going to erase. I'm going to add 6 to both sides. So 2x equals 22. Divide both sides by 2, and x equals 11. So we have x equals 11. That was a lengthy problem. Let's go ahead and move on to problem number 2. A teacher asks her students to represent the number 43 thousandths in different ways. Students showed this number in the following ways. This is for my elementary people. Everybody needs to understand place value, but this is definitely for my elementary people. So the students represented the numbers in the following ways. Student number 1 said it's 0.043. Now, I would not normally read the number that way, but I'm reading it that way to avoid reading it like this. Student number 2 said 0.04 plus 0.003. Student number 3 said 43,000 or 43,000. And student number 4 said 43 divided by 1,000. Which of the following students has a misconception of how to represent the decimal 43 thousandths and why? Now, as I'm reading this problem, I'm thinking, which of the answers is incorrect? Because we are looking for a misconception. Student 1, because the number 43 thousandths should be written as 0.43. Student 2, because the teacher did not ask for an addition expression. Student 3, because thousandths represents a number less than 1 or a decimal. Student 4, because the student does not have place value understanding and should have written 430 divided by 1,000. All right. Here's where reading the problem can really help you figure out the answer. If you didn't know what this number meant, if you didn't have that vocabulary or you froze on the test, but then you looked at the question, which student has a misconception of how to represent the decimal? Which of these is not a decimal? Which of these is not a decimal? It's the only answer that's not a decimal. So at this point, my answer is C, and I haven't even done any thinking. Now, more than likely, the question is not going to say decimal. More than likely, the question is going to say how to represent the number, and then we can't cheat like that. However, it's important for you to have those test-taking strategies because in those situations, you just earned a free point. Now let's process it as if it said number and we couldn't cheat. 43 thousandths. Here's what I want you to remember about place value numbers. If we look at a number, this is my ones place, my tens, my hundreds, my thousands, my 10,000s, and it's just going to keep going and going and going. On the right side of my decimal, I have tenths, hundredths, thousandths, 10,000ths, 100,000ths. I don't have any oneths. I only have tenths, hundredths, and thousandths. Now, what I want you to notice is on this side of the decimal, they all have a th at the end. So that should clue you in that the number is less than 1, which means it's a decimal, which means that student 3 is the one with the misconception because they're the only ones that are wrong. Now, why is 43 thousandths represented like this or like this or like this? Because I have 43 thousandths, which means that the last number in my response has to sit on that thousandths number line or thousandths place value. So if I have my place value and I know that this is my thousandths, the 3 needs to sit there and I'm going to fill in all the other numbers. And then if there's no more numbers to fill in, I put a 0 here. This would be 43 hundredths because the last number sits in the hundredth spot. So student 1 is correct. Student 2 is correct because all they did was expand that number. They did 4 hundredths plus 3 thousandths equals 43 thousandths. Just like the number 43 is the same thing as 40 plus 3, this number is the same thing as 4 hundredths and 3 thousandths. So this student is correct. That's called expanded form. And student 4 is correct because if we write a decimal as a fraction, we can take the decimal, put it on top, divided by whatever the furthest number that my decimal takes up. So this would be 43, and then it takes up the thousandths spot. So that would literally be 43 thousandths. That's how you would read that fraction. So student 3 is the only one with a misconception. All right, let's do this one. I skipped 3 for a reason. I'll come back to it. Mason has a drawer full of marbles. He has 18 blue marbles, 7 green marbles, and 15 white marbles, not markers. What is the probability that he picks a blue marble, holds on to it, and then pulls out a white marble? So this is a probability problem. Everybody needs to understand basic probability. And I made sure to go over probability problems because last week, one of our participants asked, or 2 weeks ago, one of the participants asked specifically for probability problems. So as we're studying tonight, what I want you to do is really think about what is it that really has you stumped as you're studying? What concept or what problem are you solving that you're really not understanding? Let me know in the comments before we end tonight, because then I can include it in next week or the week after's session, and I can make sure that what I'm doing is tailored to the needs that you have. So Mason has a drawer full of marbles. He has 18 blue marbles, 7 green marbles, and 25 white marbles. What's the probability he picks a blue marble, holds on to it, and then pulls a white marble? So what we need to understand first is that probability is the concept that we're going to have a part out of a whole. Probability is just a fraction. That's what a fraction is, a part of a whole. So what is my whole in this situation? How many marbles do I have total in my drawer? Well, I have 18 blue, 7 green, 25 white. So I'm going to do 18 plus 7 plus 25, and that's going to give me my whole. So 18 plus 25 plus 7, 8 plus 5 is 13, 13 plus 7 is 20, 2 plus 2 is 4, plus 1 is 41. No, 2 plus 2 is 4, plus 1 is 5. How did I get 41 from that? Holy moly, I'm tired, can you tell? All right, so we have 50 as our whole. Now, what's the probability that he picks a blue marble? We're going to stop there. What's the probability he sticks his hand in the bag and pulls out a blue marble? Well, how many chances do I have to pull out a blue marble? 18. I have 18 chances out of 50. So that right there is the probability that I'm going to pull out a blue marble. Now, what's the probability that I'm going to pull out a white marble? In this case, how many marbles are in my drawer? It's not 50 anymore. It's 49, because he pulled that blue marble out, and what did he do? He held onto the blue marble. So this is probability without replacement, is the fancy term. Probability with replacement means I pulled the blue marble out and I put it back in the bag. This is probability without replacement, which means that my white probability is 1 less, because there's 1 less marble in that bucket. So we have 49. What's the white marble probability? 25, because there's 25 white marbles. Now, how do I figure out blue marble and then a white marble? Because it's a very specific situation. It's not just a blue or just a white. It's got to be a blue the first time, and then it has to be a white the second time. To find combined probability, I'm going to multiply my two probabilities together. So that's going to equal. Now, if you know how to do all of this and then you don't know how to multiply fractions, well, you're in for a rude awakening, because this is not going to be easy if you don't know how to do combined probability, or if you don't know how to multiply fractions. So I'm going to use my handy dandy calculator. 18 times 25, 450. Divided by 50 times 49, 2,450. That's not an answer choice. That is not an answer choice. So what do I do now? I have to simplify my fraction. So I have to look for things that are factors that are common. And I'm going to show you an easier way to do this in a minute. So what do I know that both of those are divisible by? They're both divisible by 10 because they both end in a 0. So if I divide this by 10 and I divide this by 10, I'm going to get 45 divided by 245. And this is exactly what I would do if this was my test. All right. Now, what would I divide them both by? I would divide them both by 5 because they both end in a 5. So 45 divided by 5 is 9. 245 divided by 5 is 49. Now, I know that 9 is only divisible by 3, and 49 is only divisible by 7. So at this point, this is going to be my final answer. Which means when I created this problem, I did not put the correct answer. 9 out of 49 is going to be my correct answer. Donnell, you struggle with probabilities. Probability is not an easy concept. Probability and statistics is actually not my strongest suit. It never has been. I'm definitely more of an algebra-minded individual. But we all have our strengths and weaknesses, and we all definitely have to know where those weaknesses are so that we can focus on them. Why did I subtract 49? I did not subtract 49. I used 49 as my whole for the white marble probability because when I pulled one of the marbles out of the drawer, I no longer had 50 marbles. I had 49 marbles left. For instance, my husband has this bag of like the light clippies that you clip onto the house. There are, we'll say there's 100 in here. Now, let's pretend these are marbles and they're all different colors. I'm going to close my eyes and I'm going to pull it out. And I got this one. Let's pretend that's the blue one. I'm not putting it back in here. I'm holding on to it, which means I am not replacing it. I'm holding on to it. So how many marbles do I have left in this bag now? 49 marbles left in the bag because I'm not putting the blue marble back. I'm putting it in my pocket. I hope that makes sense a little bit more. Thank you, Donnell. I really appreciate the comment. Winona, when to know what formula to use is your struggle. Are you saying specifically in relation to probability, or are you saying in relation to like everything in general, like all the formulas? Let me know and I'll definitely make sure to address that in the coming weeks. Also, it would help me to know what test I know you're prepping for elementary ed. What state? Are you doing Praxis, TExES, the Georgia one, the Florida one? All the formulas. And I know you're in Michigan, so you're not taking the Florida or the TExES. Are you taking the Praxis or are you taking something else? That'll help me know so I know if you get a formula sheet or not. All right, moving on. Mason still has a drawer full of marbles. He has 18 blue marbles, 7 green marbles, and 25 white marbles. How many marbles would he have to pull out to be guaranteed to have 2 green marbles in his hand? I love this kind of problem. All right, so we have our bag of marbles. And I'm telling you right now, even to this day, I've been doing this for a really long time. Even to this day, on my test, if this was my test, I would literally be drawing this. And in here, I have 18 blue marbles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I have 7 green. 1, 2, 3, 4, 5, 6, 7. And I have 25 white. And I'm going to pretend those are the white. Okay? How many marbles would he have to pull out to be guaranteed to have 2 green marbles? This is kind of a probability problem, but it's really more of a conceptual problem. So I want you to think, if I reach my hand in and I pull out a blue marble, and then I pull out another blue marble. Let's pretend all the blue marbles are on the top, and I'm going to pull all of the ones on top first. How many marbles will I have pulled out if I pull all of the blue marbles out of the bag because they were all sitting on top? 18. Have I pulled a green marble out yet? No. Then, what if all 25 white marbles were in the middle? What would happen? I will have pulled out 43 marbles at this point, and I still don't have a green marble in my hand. Now, let's be real. Let's be real. Is that probable that that's going to happen? No. Am I going to stick my hand in that bag 43 times and never get a green marble? Probably not. But this says to be guaranteed. So is there a possibility? Wrong pipe. Is there a possibility that I stick my hand in that bag and I get only blue and white marbles? That possibility exists. And because that possibility exists, it's the only possibility we are considering for this at this point. So I have pulled out 43 marbles, and I don't have a green marble yet. But there's only green marbles left. So now what am I going to do? Pull 2 more out, because now I'm guaranteed to have 2 green marbles plus my 2 green. How many marbles did I have to pull out to be guaranteed 2 green marbles? 45. Again, y'all, is that probably going to happen? No. I'm probably going to stick my hand in there and at least be able to get those 2 green marbles at some point. But we have to consider all the options. So in this case, the answer is 45. Winona, awesome. Let me know when you find out. And you can absolutely message me on Facebook and let me know once you figure that out if you don't figure it out in like the next 28 minutes. Okay. All right, let's move on to the next problem. All right, the next 3 problems are all consecutive integer problems. Now, last week or 2 weeks ago when I was here, someone specifically asked for consecutive integer problems because these are really confusing. So I said, absolutely. So the next 4 problems, it's kind of like a little special. The next 4 problems are going to be consecutive integer problems. These problems, everybody needs to understand how to do, because the language and understanding the language and comprehending this kind of problem really trips us up. And these are really the kinds of problems that they love to ask. So yes, you have to read these because they can confuse you. So let's start with this first one. And they do get progressively harder tonight. The lengths of the sides of a triangle are consecutive even numbers. Man, already the vocabulary in this problem is really heavy. What is the length of the longest side of the triangle if the perimeter is 48? Woo! Okay, we have a triangle. I'm going to draw a triangle for us. Okay, here's my triangle. You can draw whatever kind of triangle you want. It doesn't matter what kind of triangle we have. I'm actually going to draw it like this so that the system will connect it for me. All right, there's my triangle. And we know the lengths of the sides of the triangle are consecutive, back to back, even, 2, 4, 6, 8, 10. numbers. What is the length of the longest side if the perimeter is 48? Perimeter, distance around the shape. And I'm actually going to say linear distance because it's a line. So there's two ways we can solve this. We can do this the algebraic way, or we can do this using our answer choices. I'm going to start with the answer choice way, and then I'm going to do it the algebraic way. The question asked, what is the length of the longest side? So my answer choices are what? The longest side, right? And we're looking at consecutive even numbers. So like 2, 4, 6, 4, 6, 8, 8, 10, 12, 10, 12, 14, and so on. We could go on and on and on and on and on and on forever. So if 12 was the answer, then the other two sides would be 10 and 8, because those are consecutive even numbers, with 12 being the longest side. 12, 10, 8. And the perimeter is 48. Well, what is 12 plus 10 plus 8? 30. Is that our answer? Nope. 14. If 14 is the longest side, then it's 14, 12, 10. What's 14 plus 12 plus 10? 36. Is that our answer? Nope. 16, 14, 12. Silly iPad disconnecting on me. I'm going to add 16 plus 14 plus 12. What is 16 plus 14 plus 12? I'm going to do that on my calculator so we don't waste any time. 42. Is that my answer? Nope. So 18 has to be my answer. 18, 16, 14. And when I add all of those up, I get 48. So if you don't understand how to do these problems, use your answer choices to help. So let's go ahead and talk about how to do this the algebraic way. I'm going to copy and paste this so that I have plenty of room to do it again. Let's get the biggest eraser possible. Erase, 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 erase. All right, how to do this algebraically, because not always can we use our answer choices. So if we are looking at consecutive even numbers, and I call x my smallest even number. If I add my smallest number plus my next smallest number plus my biggest number, all of that has to equal what? 48, because the perimeter is 48. Now, what are my other two spaces going to be filled with? X plus 2, middle number, and x plus 4, the largest number. Why 2 and 4? Because even numbers are 2 apart from each other. 2, 3, 4, 5, 6. So 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. And those are all consecutive even numbers. So if my smallest number was 2, I would have to add 2 to that to get my next number. And I would have to add 4 to that to get my second biggest number. And now I can just solve. X plus x plus x equals 3x 4 plus 2 equals 6 equals 48. Now I'm just going to solve. Subtract 6 from both sides. 3x equals 42. Divide everything by 3. And I get x equals 14. 14 is not my answer. And very quickly, when we solve it this way, people are very quick to come over here and circle 14. But 14 is not my answer. 14, if we go back to our key, is the smallest number because that's what we defined x as. So what is the longest number? X plus 4 is the longest number. So 14 plus 4 equals 18, which is D. 2 different ways to solve that problem. All right, let's do another consecutive integer question. The sum of the least and the greatest of 3 consecutive integers is 60. What is the value of the smallest integer? All right, again, you can use your answer choices to help you. Do not let this kind of problem stump you. The answer choices are right in front of you. So if they ask, what is the value of the smallest integer? Then my answer choices are the smallest integers. And we're looking at 3 consecutive integers. Integers are just counting numbers. So we're not looking at 3 consecutive even or 3 consecutive odd. We're just looking at 3 consecutive numbers. So 29, 30, 31, 30, 31, 32, 31, 32, 33, 32, 33, 34. Now, what did that first sentence tell us? It said the sum of the least and the greatest. So the smallest and the biggest of 3 consecutive integers is 60. What does the sum mean? The answer to an addition problem. Okay, so I have the answer to an addition problem, and I'm adding the smallest and the biggest numbers, and it all has to equal 60. So something plus something has to equal 60. The 3 is going to really throw people off because they're going to automatically think that I have to do something plus something plus something to equal 60. But it is. So in this case, I'm looking at 29 and 31, 30 and 32, 31 and 33, 32 and 34. Well, which pair of those is going to equal 60? 29 and 31. So A is the right answer. Now, how would you solve that algebraically? Well, great question. Let's duplicate it and do it algebraically. All right. How would I solve this algebraically, not using my answer choices? Because quite frankly, I am not an answer choice kind of person. I'm a very algebraic thinker, so I'm going to solve it algebraically if I can. So I'm going to define my variable. X equals my smallest integer. In this case, what is my middle integer going to be? What is my middle integer going to be in this case? X plus what? X plus 1. Because I'm not even or odd. Even and odd are going to get an X plus 2 because they're 2 away. But to get from 29 to 30, from 30 to 31, from 31 to 32, from 32 to 33, it's just adding 1. And then x plus 2 equals the largest integer. Now, what did they say? They said the sum, addition, of what? The least and the greatest. Something plus something, which is going to be the least and the greatest. X plus 2 is 60. Solve. X plus x is 2x. Subtract 2 from both sides. 2x equals 58. Divide both sides by 2. X equals 29. Same answer. 2 different ways to solve it. All right. This one is fun. Now, this one, we cannot use the answer choices to help us as much as we've been able to in the other two. So in this case is when it is critical that we understand how to read and interpret and solve these kinds of problems. The sum of 4 consecutive integers is y. Which of the following represents the sum of the first 2 integers in terms of y if the first integer is equal to x? This problem sounds so cumbersome, but I promise it's not. You know what the sum means. Sum means answer to an addition problem. 4 consecutive integers, 4 back-to-back numbers is y. So something plus something plus something plus something equals y. Which of the following represents the sum of the first 2 integers in terms of y? I'll get to what that means in a minute. If the first integer equals x. Well, if the first integer is x, then that means the second integer is x plus 1. And that means the third integer is x plus 2. And that means the fourth integer is x plus 3. So I can plug those in. X plus 1 plus x plus 2 plus x plus 3 equals y. Let's simplify that. X plus x plus x plus x is 4x. 3 plus 2 plus 1 is 6 equals y. Now, they want to know the sum of the first 2 integers only in terms of y. Well, if we're doing it in terms of y, we have x plus 1 is the sum of the first 2 integers. X plus 1 is 2x plus 1 equals y. If we're doing it in terms of y, we need the y to be the star of the show. So it's not going to be A or D, because in those, the x is the star of the show. How do I get this to be in terms of y? Well, I need to plug in a y value for the x. So I'm going to simplify this and plug that in for x. So I need to put that in terms of x. You lost me. I'll get there. Once I finish it, you'll kind of see and I'll wrap back around. So if I do 4x plus 6 equals y, subtract 6 from both sides, I get 4x equals y minus 6. Divide everything by 4. then I get x equals 1/4 y minus 3/2. Did you follow that? All I did was take this and solve it for x. Now I'm going to take my x value and plug it into here. So 2 times 1/4 y minus 3/2 plus 1. Distribute my 2. So 1/2 y minus 3 plus 1, 1/2 y minus 2. B is my answer. I kind of just like bulldozed through that problem because I needed to bulldoze through it so that I could kind of go back and explain it. What grade is this problem? This has the potential to be on a middle school or a high school exam or a core or a GK. This is most likely going to be seen on like a 5 through 9 or a 6 through 12. Not elementary. This would not be seen on elementary because the amount of variables that you're seeing is not going to be elementary. So in terms of y means that I need y to be the star of the show. So what I did was I took my first 2 integers, added them together, and got this. Then I took my whole problem and figured out what x would equal so that y could be the star of the show. So I took that and solved for the variable of x. All I did was move things around. So what I want you to visualize is one of those pan balances. If I take 6 out of here, then I have to take 6 out of here. If I dump 5 into this one, then I have to dump 5 into this one. So all I'm doing is moving things around, but I'm keeping that balance balanced. So I subtracted 6 from both sides. I divided everything by 4, and I got x equals this. Then all I did was substitute out the x for all of that because x is the same thing as 1/4 y minus 3/2. They're the same. So I substituted out the x for all of that and simplified. If you don't understand this problem, but you understand this one and you understand this one, you're in a good place. Let's do one more. This one's back to a little bit of the easier kind. The sum of 5 consecutive odd integers is 45. The sum of 5 consecutive odd integers is 45. So I know that something plus something plus something plus something plus something is going to equal 45. Something plus something plus something plus something plus something has to equal 45. Which of the following represents the product of the third integer and the sum of the first 2 integers? Holy moly. Everybody needs to be able to understand how to take this sentence and interpret it. Let's start with the first section because I can't find the product of the sum of all this stuff if I don't know what my 5 integers are. So if x is my first integer, and I know they are consecutive, they're back to back, odd integers, then x plus 2 is going to equal the second number. X plus 4 is going to equal the third number. X plus 6 is going to equal the fourth number. And x plus 8 is going to equal the fifth number. Even and odd numbers are all 2 apart. So x plus 2 plus x plus 4 plus x plus 6 plus x plus 8 is all going to equal 45. Now, if you struggle with that and you can't use these answer choices to help you in this situation, think about this. 1, 3, 5, 7, 9. I could sit here and go 1 plus 3 plus 5 plus 7 plus 9. That equals 25. Not enough. Let's start with 3. 3 plus 5 plus 7 plus 9 plus 11. That equals 35. Not enough. Let's start with 5. 5 plus 7 plus 9 plus 11 plus 13. That equals 45. So 5 plus 7 plus 9 plus 11 plus 13 all equals 45. We knew the numbers weren't going to be huge, so I knew that I could start low and go up from there because the sum is only 45. Could I solve it algebraically? Absolutely. I could sit there and add all the x's. 5x plus 20 equals 45, and I would get x equals 5. Now, what is the product of? That means the answer to a multiplication problem. Something times something. The third integer, 9, and the and separates what I'm multiplying. The sum of the first two integers. What is the sum of the first two integers? 12. 9 times 12 is 108. And that's my answer. All right, that was a lot. I'm going to turn it back over to Dr. A for him to close us out and give you guys a special code for hanging out all night. What I do want you to do is let me know in the comment box what you want to see me work through in the next coming weeks, next week and the week after. What do you want to see me work through? What are you really struggling with? I've got like figuring out what formulas to use for sure, and I'll continue to work with probability as well. If there's anything else you want to see me work through, let me know in the comments, and I will see you guys next week for a special Thanksgiving edition, because then the next day is Thanksgiving. So I'll see y'all next week. I'm going to turn it over to Dr. A, and have a good rest of your week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.